Alrighty, how's everybody doing? We are going to look at medians and altitudes today, expanding on our perpendicular and angle bisectors from yesterday. So we want to be able to identify the differences between medians, altitudes, angle bisectors, and perpendicular bisectors. So basically, four different lines that do different things, and sometimes a combination of things inside a triangle. So first of all, a median is a segment from the vertex. So in this case, it's x from the vertex of a triangle to the middle, median is middle, of the opposite side. In other words, the median bisects the opposite side. It creates a midpoint over here. So we have XA is a median right now, which means YA is now congruent to AZ. Okay, so if we look at this example, XA is a median, which I just said. Mark the diagram appropriately, then draw medians ZP and YL and label the diagram. So ZP, you only see a Z, so that means it's this other vertex, so we're now going to draw it and try and hit a midpoint on this other side. So we have this, and then we also have going back the other way, so we're going to call that ZP, and then YL is going to go from here back again. Try and get in the middle. It might not be perfect, but go ahead and try and get it back. And you'll notice that we intersected right there in the middle somewhere, which is right there. Okay. So the special name for those points A, P, and L, something again that we've talked about, if they're cutting the side in half or they're creating a middle point, we would call it the midpoint. So if I told you AZ was, or I'm sorry, if I wanted to find AZ, if YZ is 24, simple as this, AZ has to be half that because it's been cut in half. So AZ would be 12 centimeters. Which segments are congruent to each other? Okay, so we're just getting in the habit of making sure we know which ones are congruent, and which is why I marked YA differently than I marked YP. If we used just one little hash mark for each one, it looked like we have a bunch of segments that are congruent to each other, which isn't true. But what we can do is go ahead and say, okay, YA is congruent to AZ. We have XL is congruent to LZ, and we have XP is congruent to PY. Okay, so we have all those things that are true. They're not all congruent to each other, but they all have congruent sides in there. Label the intersection of the three medians as I, which I already made a point, but now I'm asking you to label it as I, which would be that point there. And what we call that is the centroid. So the centroid is right there. Yesterday, you guys had circumcenter that we talked about. Today we're adding on centroid, which is where the three medians of a triangle intersect, right at that intersection point. So that's a median. Goes from one vertex, cuts another side in half. An altitude is a segment from the vertex of a triangle, so in this case A, that is perpendicular to the opposite side. And altitude forms right angles. Okay, so that's what this does. It does not cut JC in half. That's what a median does. So you guys might be thinking, okay, I've seen altitude, I've kind of seen median before. What we have seen really is a perpendicular bisector. We talked about that yesterday. An altitude is the 90-degree part. Median is the part that cuts it in half. Together, altitude plus, and you guys might even want to make a note of this, but an altitude plus a median, both parts of that, gives you your perpendicular bisector. Okay, so we're just breaking those two parts down today. So if we look at this example, AK is an altitude. Mark the diagram appropriately, then draw altitudes CO and JP and label the diagram. Okay, so if we know that this is an altitude, I've already marked what I know. That's all I know. I do not know that JK and KC are congruent. I cannot make that statement. So what I'm going to do is I'm going to finish this diagram, and I'm going to go ahead and draw as best I can JP. So it's going to be here, and again this is going to be a 90. Notice it doesn't cut the AC in half, it's just making 90. And let's see, CO, which is going to go back the other way. That's an awful line. Let's fix that a little bit better. Except now I can't draw my box. There we go. So we have CO over here. Okay? So if we think about this, we want to know what is the measure of JKA, COA, JPC. Well, if you look at all those angles, so JKA is right down here. We know that COA goes from C to O to A. Remember that middle letter is where the angle's happening. And JPC, so from here to here, right here at P, those are all going to be 90 degrees because they're all right angles. Okay, not too bad at all. Label the intersection of the three altitudes as M, so we're going to call this M, and that's called the orthocenter. So that point there is called the orthocenter. So now you have orthocenter, centroid, okay, circumcenter, incenter. So you have four different things where different altitudes, medians, angle bisectors, perpendiculars, bisectors meet. Just things that you want to be aware of, you want to make sure you know for a quiz or a test. So that's an altitude. So if we look at a few examples, that's all we're looking at today is medians and altitudes. If I tell you that triangle HKA, so always give yourself a picture. Triangle HKA has a median, so let's go ahead and draw this. Median HJ, which means we're going to go from H to this side and cut it in half because it's a median. We also know that HJ is perpendicular to KI. Okay. HJ is 6x minus 8. So this is represented as 6x minus 8. KJ is x plus 10, so some number plus 10, and JI is 2x minus 20. Draw the figure and solve for x. Okay, so I've got some different things in here. You need to decide what you want to do. Well, the only true statement that we can say is that KJ and JI are congruent. We don't know if HJ is congruent to JI or KJ, so we can't say that. But what we can say again is that x plus 10, KJ, is equal to 2x minus 20. Subtract x and add 20 back to the other side. So x is 30. Not too bad at all. If HJ is a median and altitude, which it was, because I told you it was a median at the beginning, and then I told you it was perpendicular, this is our special name that we talked about before. Altitude plus a median makes it a perpendicular bisector. It does both things. It's perpendicular and it bisects. Okay, if we look at a couple more examples, I'm going to save one for you guys tomorrow, but example 4. Okay, so triangle KCT has vertices, okay, 12, negative 6, 9, 2, and 2, 4. Determine the coordinates of M on KT so that CM is a median. Okay, so let's take a look at this. Determine the coordinates of M on KT. So that's going to be M is going to be right here. And we want it to be a median. So we want these two to be congruent to each other. Okay, so a little bit tougher problem, but we want to think about what we want to do here. If we want it to be the median, okay, so we want M on there and we want CM as the median, which means this is going to happen there. That means that CM needs to be cutting KT in half. In other words, M has to be the middle, or what we call the midpoint. So we need to find our midpoint. The way we do that is take the average of our two x's and average of our two y's. We've done this a bunch. So 12 plus 2 divided by 2. negative 6 plus 4 divided by 2 and simplify. So we have 12 plus 2 is 14 divided by 2 is 7. Negative 6 plus 4 is negative 2 divided by 2 is negative 1. Okay, so that makes this 7, negative 1, which would be right in the middle of k and t. Okay, now what we want to do, now what I'm asking, is cm an altitude as well. Okay, altitude should ring a bell, we just talked about it. Altitude means 90 degrees. In other words, we want cm to be 90-degree angle with kt. Okay, so what we're going to have to do is find the slope of kt, the slope of cm, and decide if they're perpendicular. So let's find the slope first of, let's do cm first. So cm's slope is going to be 2. So we have our 2 plus 1, because it's 2 minus a negative, so 2 plus 1, over 9 minus 7 is going to give you 2 plus 1 is 3, over 9 minus 2, so we're going to have 3 over 2. So that's the slope of cm. Okay, hopefully not too bad so far. Again, just slope formula. Now we need to find the slope of kt. So we're going to go ahead and do the same thing, but between k and t. So we're going to have negative 6 minus 4. You could also do 4 minus negative 6. It doesn't matter. Negative 6 minus 4 over 12 minus 2. Remember, if you do it negative 6 minus 4, you have to do 12 minus 2 to keep in the same order. Negative 6 minus 4 more is negative 10. 12 minus 2 is 10, which equals negative 1. So our slope of kt is negative 1. Okay, so we have 3 halves, we have negative 1, clearly not perpendicular. We would need it to be like 3 halves and negative 2 over 3, or negative 1 and 1, but these are not perpendicular, so it is not an altitude. Alright, last example that I want to take a look at with you is example 5. I'm going to have you guys do example 6 tomorrow at the beginning of class, so save that one for tomorrow as a warm-up. BK is a median. Right away, that's a keyword. Mark it. Solve for x and determine if BK is also an altitude. Okay, so first let's solve for x. I just marked what we need to know is true. That is, EK is congruent to KO. So what we're going to do to solve for x is say, okay, negative x plus 35 has to be equal to 2x minus 1. I'd like you guys to pause it, work ahead, see what you guys get for x. Okay, hopefully you found out your x and see if you get the same thing I have. So let's go ahead and add x. Add 1 back. And divide. Okay, so x is 12. Now determine if BK is also an altitude. Another key word there. Altitude means that this would have to be 90. Again, don't go off of what it looks like. Just because BK and EO don't look perpendicular doesn't mean they aren't. Okay, I'm not going to just show you they're perpendicular. I want you to decide if they are perpendicular. So what you need to do is to see if that angle is 90 degrees. Okay, so we're going to go ahead and plug in here to see if that ends up being 90. So we have 7 times 12, which is going to give us 84 plus 6, which is equal to 90. So that tells us that that is in fact an altitude as well. Okay. Example 6 I'm going to have you guys do in class is kind of the opposite of what we just did. I tell you it's an altitude. You're going to solve for x, and then you're going to determine if KL is a median. Okay, so save that one for tomorrow. You can look ahead at it, you can try it, but be ready to work on that one in your groups tomorrow. See you guys.